In this video, I'm going to look at the next 4 examples. I'm going to look at KH, Na2O2, PbO2, and P3. So first thing, start off with classifying what type of formula it is. Is it an individual element, a compound, or just a polyatomic? So KH, this would be a compound. Na2O2, this would be a compound. PbO2, because there's 2 different elements, it's a compound. And this structure, the only symbol I see is a P, so this represents an element. If you classify the structure like KH as a compound, when you add up the oxidation states, the sum needs to be 0. So in this structure, I have K and I have H. So here we go. I notice in this structure it has H, and H is bonded to K, which is a metal. So when H is bonded to a metal, it uses its -1 charge. There is only one K present, and so that K, by default, I can figure out mathematically, uses a +1, because +1 plus a -1 equals 0. Now, when I take a look at this next example, Na2O2, I'm going to just keep working through this as I've done all of the others. So I notice that in this structure, okay, it contains oxygen. And so when it contains oxygen, I have to ask myself, is this common oxygen, a possible peroxide, or oxygen bonded with fluorine? Well, I can see really easily that oxygen is not bonded to fluorine. This formula ends in O2, which means it's a possible peroxide. So I have to check myself if it is a peroxide. If it's a peroxide, O2 must be bonded to hydrogen, a group 1 cation, or a group 2 cation. So when I go find Na on the periodic table, Na, this is in fact a group 1. So what this means is that yes, this is a peroxide. So this is a peroxide. Oxygen, each oxygen in a peroxide, we assign it a -1 charge. So the 2 oxygens, each using a -1, collectively supply a total charge of -2. When we add that to the Na, the sum, because this is a compound, still needs to add up to 0. Well, I have 2 Nas. Both of those Nas collectively, whatever they supply, needs to cancel a -2. So I need this to be a +2, but there's 2 of them. So mathematically, I would assign each Na a +1. When I take a look at the next example, like the one before it, let me get myself set up, is I have a Pb, and it's forming a compound with oxygen, and there's 2 oxygens. So whenever my formula for oxygen ends in O2, I have to think, is this a peroxide? Okay, so what I have to do now is I have to take a look. Where is Pb? Pb, it is not a group 1, so it's not in group 1. It's not in group 2, and it's definitely not H. So since Pb is not in group 1, group 2, and it's not hydrogen, this is not a peroxide. So if it's not a peroxide, then it uses its common oxidation state of -2. So in this case, 2 oxygens, each using a -2 charge, it provides a total charge of -4. When you add the total negative charge of -4 to Pb, the sum still has to be 0. So that single PB needs to supply enough charge to cancel out -4. So mathematically, the PB must be supplying a +4 charge. Now, our next example is the element phosphorus. And because this is an individual or free element, life is easy. We just simply assign it an oxidation state of 0.